Hello, my name is Iris Cristina Arbizu de Leon and I will present my project. Electrochemical performance of LACCASE immobilized in titanium dioxide for this potential use as a biocathode in microbiology electrolysis. Microbiology electrolysers are a promising approach to obtain green energy, but present a big problem. That is the high manufacturing cost due to the high cost of the material used in the cathode. For example, platinum and gold, which are normally precious metals. That is why they use biocathode is a good alternative. They use ability of some oxidoreductase enzymes such as LACCASE to enhance proton reduction in hydrogen evolution reaction. The objective of this work is evaluate the LACCASE enzyme Trametes versicolor to covalent immobilized of chemical modified titanium dioxide nanoparticle for this potential use as a biocatalyst. Reviewing the methodology, first the titanium dioxide sulfide was chemical modified with the APTMS reagent to leave silane groups exposed. Then glutaraldehyde is added as a linker to later to able to covalent bind the LACCASE enzyme. And the next step is the characterization is performed by C-potential electron spectroscopy for chemical analysis, scanning electron microscopy, Fourier transform inferred spectroscopy, and of the simple and modified titanium dioxide material. And the next step, the enzyme-loaded nanoparticle we absorb on a glass carbon electrode for electrochemical characterization by cyclic voltamperometry, electrochemical impedance spectroscopy, and finally, the most important test, the hydrogen evolution test by linear scanning voltamperometry. Starting the result, the figure 1, the XPS spectrum is present where I can be see how the addition of APTMS decreases the peak intensity for a titanium dioxide, and double peak is presented in the oxygen windows indicate the formation of the silicon-oxygen bonds, and will has present of nitrogen which indicate the amino group has correctly attached to the surface of the nanomaterial after the addition of glutaraldehyde. Increase the intensity of the carbon peak corresponding the carbonyl bond present and decreases a little that a silicon. Continuing, we see the absorption peak at 2933 has attributed the carbon-hydrogen bond for the methyl groups. Like the other, the 1443, there are vibration of nitrogen carbon due to the reaction between the hydrogen groups for glutaraldehyde of the amine group of titanium dioxide amine. Once LACCASE with added has a band of 1505 and 1650 appear corresponding the stretching for carbon oxide. This is the amine band 1 and the other is the nitrogen hydrogen band. This is the amine second band. This is the LACCASE and this is the protein. And in the other figure, you can see the same images. We can see the change of morphology when glutaraldehyde is added, giving the nanoparticle more agglomerate appear and losing the original circle form. Figure 4 shows the voltamperograms of time by electrode at each immobilization step. It can be seen the presence of titanium dioxide nanoparticle alone does not improve the oxidation and reduction potential if you compare that the glass carbon electrode. However, the chemical modification of titanium dioxide plus the immobilization of LACCASE improve the potential response present and increase the oxidation and reduction current peaks, which show the LACCASE immobilized of titanium dioxide improve the electrocatalytic activity. It might be due to the activity LACCASE Cooper centers. And in the electrochemical impedance spectroscopy, we also use to investigate the effect of electrode modification. The Nyquist diagram shows the presence of capacitive semicircle in the high frequency range and the linear region for low frequency data, which is the typical for of fusion charge transfer process. That is solved of this work is that the RCT that was less has that his LACCASE, which they indicate that the transfer of electron is more easy cleared of when the LACCASE is immobilized in the nanomaterial. And finally, linear sweep ball tamperometry was used to evaluate the kinetic for with the evolution for hydrogen. The polarization curve present shows that with the modification of the electrode with LACCASE, the overpotential decrease and the cathodic cross increase at the potential of minimum 1 volts. And then the other, the slope analyzed, the Tafel slope present showed that the LACCASE modified electrons that the Tafel slope decreased to minimums 142 millivolts per decade. The lower the slope, the lower the potential need to reach the same current, indicate that better hydrogen evolution is possible when the LACCASE is present and is very good for our works. And the conclusion, LACCASE immobilized on titanium dioxide exhibit a significant increase in oxidation and reduction of current peaks compared to beer and titanium dioxide modified glass carbon electron. Beer titanium dioxide nanoparticle produce a negligible change in the voltamperometry response comparative to glass carbon electron. Cinet to redox process is similar for the glassy carbon electrode alone and with titanium dioxide, but the electron transference was greatly improved of LACCASE based bioelectrode. Polarization group showed the overpotential decrease and the cathodic current increase for the LACCASE base electron properties required for hydrogen evolution. In summary, LACCASE immobilized on titanium dioxide could be promising BIOCATHODE for a microbiology electrolysis cells. And thank you for your attention.